Okay, so we are going to learn how to derive some of the more basic kinematic equations that you're going to need for future classes and just in general. These are taken from the few that we've already learned. So these are going to be a little more advanced and are going to be used in a little more situations. So let's just begin with the first derivation. I've written it all out. I'll explain it here. So at the beginning, as you can see, we have our basic equation for acceleration that doesn't change in x over change in t. And, change in v over change in t, excuse me. And then I break down change in v a little more. As we both know, delta v means change in v, which is just vf over vi. So that's a pretty simple thing that we've already learned, and just to review for you, it just means a change in something. So vf, v final, versus minus v initial is the change in velocity. Then a, acceleration, we can substitute this delta v for this delta v and get this. Pretty simple still. And delta t becomes t because right now we're just starting from 0 all the time, so we can just say, oh, 3 seconds have passed, the time is at 3 seconds. Okay, and that'll change in the future, but for our intents and purposes, this is how we're going to notate it now just to make it simpler. We multiply both sides by t, some simple algebra. So to get rid of a fraction, you multiply by the denominator, which in this case is t. Okay? So once you do that, you have vf minus vi equals at. Then you move vi to the other, then you move vi to the other side, and you get v final equals v initial plus acceleration times time, and that will give you velocity. Okay, so that's our first derivation. Take some time, copy it down, pause the video if you need, and on to the next one. So I said equation 2, but I meant derivation 2, but same thing. So now we're working with velocity. So velocity is change in x, change in distance, over change in time. Again, we're just going to change the change in time to t, but we're going to look at what this velocity is. So every time we talk about these basic equations like velocity equals x over t or acceleration equals v over t, we're really talking about averages. So how do you do an average? Well, it's a mean. It's an arithmetic mean. So you take all the data and you divide by the number of data, which is shown here. So v, we're only working with two velocities. So v is, that should be a vi. Okay. So v is 1/2 then the sum of the two data points. So it's the sum of the two data points, which is vf and vi. Which should also be so it's vf and vi, as you can see after I fix it. And then over 2, these are two data points, vf and vi. So it's the sum of two data points over the number. Okay. Over the number of data points. So now we are going to place that in for v. Do that. And we're going to get a new equation for x. So once we multiply both sides by t to get x out of that fraction, we now have 1/2 vf plus vi. That should not be a v0 times t. Okay, we're going to be using that later. On to the third one. Let me give you guys a second to copy this down. Remember, a v0 is just vi. I just confused myself there. Okay? Derivation 3. So, this one's a little more complicated, but we start with a equals v0, vf minus vi over t, which is just change of velocity over t, right? We know that already. And then we're going to rewrite the equation that we just derived, equation 2, which is x equals 1/2 plus times vf plus vi times t. We're going to multiply those two together. Once you do that, you get this beast right here. 1/2 VF plus VI times the quantity VF minus VI. So now through some fancy multiplication, we get this. Now, really all I did was I multiplied each side by 2 to get rid of the fraction. And then I FOILed the two binomials. If you need a review on that, let me know next class. And then once you move some stuff around, you get VF squared equals V0 squared or VI squared, whichever one you want to use, plus 2AX. Or if you just want to find for VF, it's VF equals the square root of V0 or VI squared plus 2AX. Take a minute to copy that down. Okay. Last equation. So now we're working with equation 1 again, which was the first one that we derived today, was VF equals VI plus AT. And we're working with the third equation again, with the second equation again, which is X equals 1/2 VF plus VIT. And we're gonna substitute in VF in the second equation with the first equation. So VF is still equivalent to VI plus AT, so we put that in for the X equation, and we get this. And then we collect like terms, and we get X equals 1/2 times quantity 2VI plus AT times T. Then we break it down. And finally, after simplifying everything, we get delta X equals VIT plus 1/2 AT squared. Now, this is delta X, so remember it's X final minus X initial. Okay? So remember, anything with a delta is actually two quantities in there. So if you ever need to find X final, you have to break it down. Okay, we'll go over this a little more in class tomorrow. Alright. Bye.